Pleasure being here, fourth time, and a pleasure every time. I know it's the last session on... All right, let's try to avoid this. Anyway, Selamat Petang. I hope you've been enjoying the day so far. I know this is the last session. I know it's been quite a long day. You need the energy, you need the coffee, and I'm holding you from the dinner. So I'll do my best to keep it as engaging as possible. And to make it a bit difficult for the cameraman, I'll be walking around here. All right. So what I intend to cover the next 4 hours is, next hour or so, will be first of all discussing the value of testing, looking at the organizational context of testing, a bit about software quality, how to quantify quality, how to measure quality, how to test for quality, how much testing is enough, and last and least, of course, how we can create the business case for testing. One last element is I'm going to, at the end, also address a bit about what about agile projects and how can we personally increase our values as testers. All right. Let's start, first of all, an introduction. I come from a big company called Cognizant. Cognizant, a big IT service provider. I'm not here to promote or advertise for Cognizant, but the fact is, it is a big global player. Today, our revenue is about $12 billion, of which 18% comes from testing services. So we're talking about $2 billion of testing revenue in Cognizant. Now, for us, making the business case for testing is something you do on a daily basis. Basically, we need to make sure that our customers appreciate the service that we're providing and are willing to pay the price for it. So during my talk, I'm going to show you examples of how we can try to put some dollar figures, some values on making the business case, the financial business case for testing, knowing that, of course, there are some constraints, there are some limitations. And those of you who have been here also in a panel session, we've also discussed that sometimes can be difficult putting a dollar figure on something that is a bit intangible. All right. This is my testing process. This is a testing conference. I've simplified, removed all the other unimportant aspects, so this is my testing process, all right? I think your process might be slightly more sophisticated, I hope. What happens in testing? We have an application on a test in a certain version, version X or 1, coming into testing. Yes, and what do we do? Putting a lot of effort, money, tools, people. Now what comes out of it? Application on test, version X or 1. Right? Now if you look at it from a manufacturing point of view, from a business point of view, it seems like a rather poor process, doesn't it? I mean, imagine a production line, you're putting a lot of stuff in there, spend a lot of time and money, and what comes on the other side is the same thing. So I must be getting something else besides the same version of software. What is it? Anyone? Anyone? I'm going to pick one in random. You, sir. Yeah. What are you getting out of the process? You get the testing tomorrow, give it to you, please do some testing. After you finish, software is the same. What did you get out of it? Yeah. Defects? Okay. Let's assume, just for the sake of discussion, that you did not find any defect. Did you waste your time? Sorry? Now, in testing, I've got some points here. You're getting knowledge, getting information. Now, in testing, we're not changing the binary of the executables. What we're doing is we're in the business of providing information, yes? Now, my main task is providing good information for some decision makers. Now, I believe if I do my job properly, people want to put value on the information that they're getting from me, yes? Now, let me ask you a question. Do you subscribe to any kind of media? like your favorite magazine or paper, whatever. Yes. Might be online, might be paper-based. Why do you choose to pay for certain media or information sources or magazines? Anyone? Ma'am, I'm picking you random here.
My interest.
Because you're interested in. All right. Now, I believe, as mentioned, since we are in a business of providing information, if we make our information that we provide specific, meaningful, relevant for the audience, timely, then people want to subscribe to this information. They want to get for it. They want to pay for it. All right? This is, I believe, the main objective of testing. And there are different ways of providing this information. Nevertheless, it remains the same that your main objective task is being a service provider where its main service is providing relevant information for your stakeholders. Now, if you're providing good information, you will give them good basis for making some good decisions, yes? All right. Now, again, I'm looking at the world from a testing point of view, and basically this is my organization. I have testing, and then I have the remainder of the organization, yes? Testing is the most important, of course. What we tend to forget is, of course, that, first of all, we are a service organization. We're not putting the defects in. We're not even removing them, yeah? So we're not creating the quality itself. We're just looking for it. And someone else will, for example, be taking care of fixing those. Hopefully, it will lead to better quality at the end, but this is just not my task. I'll get back to that point. All right, so another question. I'm going to raise a few questions here just to get some interaction here, and then we'll try to tie the whole thing together and try to create a business case. Let's discuss quality. Obviously, what we're doing in testing, we try to measure or we try to assess the quality of our systems, of our software. Yes. What is quality? Imagine a quality product, whatever that means for you. It might be I don't know, it might be Candy Crush for you, it might be BMW, it might be the latest Galaxy 7 Edge, whatever, okay? What makes this a quality product? Let me ask you, sir. Defect-free. Defect-free, all right. We'll get back to that. Other points?
User certifications.
Certifications, sorry?
User certifications.
User satisfaction, excellent. Other points? Fulfill your needs. Good point. Other points? Works as expected. Good one. Bug-free. That's a big of a statement, doesn't it? But anyway, we'll get back to that. We'll get back to that. There are different views, and there are different famous quotes about what is quality. One is, of course, conformance to requirements. So if you are creating a software specification or requirement and you're meeting those requirements, then of course you're providing quality. Another thing is fitness for use. I think you got the point here from a couple of participants here. Third one, I love this one. Quality is pride of workmanship. And I think sometimes, we're missing that in some aspects of the software industry. Now imagine I'm producing chairs, all right? I'm producing this chair. Now, conformance to requirements. Now, if I build this chair exactly according to the specification, is it a good quality product? Might be. Of course, only if I'm capturing the right requirements, yeah? If I've forgotten some requirements, then it might not be that good product. Fitness for use. Obviously here, different aspects, more of a user point of view. But still, if I'm building it according to something that will be perfect for our users in the user situation, it might be a good product. Imagine now, instead of this one, I'm creating an antique piece of furniture. Here, definitely is not, it's not conformance requirements, because if, typically if it's an antique piece of furniture, it will be handcrafted. It will be, some small deviations here and there. It will not be manufactured by machine, which will create exact replica of the chair. But this might give me a better sense of quality than, for example, someone that exactly meets the conformance requirement. All right? The point is, quality is in the eye of the beholder. So what constitutes a good quality product for you might be different than for myself. Yeah? And sometimes you have these debates, I think iPhone is a good product. Otherwise, no, it's rubbish. And you have these discussions because these are based on your subjective evaluation of this particular product. So how do you, if you're in the business of assessing the quality of your software, how do you do that? Quality is a multidimensional entity. So the only way of achieving that is assessing multiple dimensions. Yes? Now, different ways of putting together what constitutes quality. One attempt was done by ISO 9126. Actually, it has been superseded now by a newer standard. I'm still referring to that because I think it has a simplified view of quality. But basically, according to that standard, what makes quality is basically these 6 main characteristics: functionality, reliability, usability, efficiency, maintainability, and portability, of which each is broken down to further sub-characteristics. So if we take, for example, reliability, it's made up of maturity, fault tolerance, recoverability. Now, I use this as a checklist to remind me of some of the things I need to test for in my products. Now, here's the interesting thing. If you look at these characteristics or sub-characteristics, some of those might be supportive to one each other. Others might be conflictive, might be pulling different directions. So again, I'm going to pick someone random in the audience. My fellow speaker here. Can you point at one, for example, that can be conflicting with the others? Interoperability.
Yeah.
And?
Conformance.
And conformance. Why?
It can be conformed to your specification. I'm just thinking about the FDA rules. It's conformed, but it cannot operate with other APIs and other rules.
Good example. Other examples here in the audience. What about usability? This one here. Does it conflict with any other characteristic? It's a quiz. Fault tolerance. How come?
Because if you try to make your software in the level of real 100% fault tolerance, that means the software become more complex, and then it will jeopardize your usability because of this issue.
Good point. Another point can be, for example, let's take usability and security. Do you think it's conflicting or supporting one each other? When a system tells you either your username or password is incorrect, why doesn't it tell me which one is incorrect? From a usability point of view, I think that's poor usability. But from a security point of view, it's good that it's not telling you which one is incorrect. Yeah. The same with performance. Performance can conflict with many of the others. If you want, for example, maintainable small code, then obviously, I think maybe performance can conflict with most of those on the others. Performance basically is a combination of the time behavior and resource utilization. But anyway, so my point is there are different characteristics that constitute quality, yes? So what happens when you're in a situation where you need to make a trade-off? Who has the final word? Stakeholders. As a tester, Again, as we were discussing before, we are information providers. We're not in a position to make these trade-offs ourselves. We can provide some knowledge, some information about how it's behaving according to those. But if you have a conflict, someone will need to make a decision. Do we go for maintainability or do we go for performance and go for security? Hold on to that thought. Again, back to our role as testers. Now, when it comes to releasing software, the big question is, of course, when is the system ready to ship? Yeah? And many organizations have one single criterion, which is the release date. Using this criterion is very easy. You just need a calendar and maybe a good portion of faith. Yeah? So we have this classical Dilbert comic. You probably have seen those in the past. I'm a big Dilbert fan, saying, we still have too many software faults to release. Well, move the list of faults to future development and ship it. All right? That's one approach. Anyone using this approach, by the way? I hope not. All right. So how much testing is enough? We had, we were discussing this before in the previous session, in the panel discussion. Now, this graph is very old, actually. It goes back to the 70s. It's by Duran. Basically, what you see here, this is the cost, and this is the quality level. Obviously, the cost of finding and correcting defects, this is the one that is shown in red here. And the blue line shows the cost of failure. Now, if you release a system very early, then of course quality level will be quite low. Of course, the cost of finding the cost of fixing and finding will be very low. Yeah, the total quality will be the quality level will be very low at that point in time. Yeah, so if you release at that point in time, you probably have high cost on the system support, angry customers, the mobs, coming to your headquarters and demanding for better quality. Yeah. On the other hand, if you keep finding and correcting defects, then obviously the cost of quality, of course, the cost of failure will go down, keep going down, and the soft cost of quality will increase. So when is the optimal level? This is basically when you have the sum of these two curves. This is where you hit this point. What does it mean? It means that after I've passed this point, it is much cheaper for me to let my end users find the defects. Simply here, it becomes too expensive finding defects because, again, back to the business case, it's more worthwhile, it's more feasible to let our customers find those defects. Are you with me? Heavy stuff in the afternoon, I know, so bear with me. Now, let me make an analogy. Maybe you've heard that before. Have you ever made popcorn yourself? Popcorn, you know what's popcorn? Hold on. Do you have the recipe for making popcorn? I mean the old-fashioned way, where you put it on a stove. You know how to do it? Anyone? I'll try with the other end. Do you have the recipe, ma'am? No. Anyone? Okay, let me share the recipe. It's quite easy. Yeah? You take basically your popcorn. Yeah. That's, first, you need a pan. You need popcorn. You need some oil. Put it on the stove. Yeah. And have a lid, of course. And then you turn the heat on. Yes. What happens? Pops. Yeah. First, very slow pops. Yeah. What happens then? Start popping faster and faster, yeah? At the end, start slowing down, yeah? Now, this is a bit like if you're doing old traditional testing, finding defects. In the beginning, it's very slow because you've only developed a few parts of the system. Some parts might be blocked to the others, blocking defects and so forth. Suddenly, you come into the area where you start a lot of functionality coming in, you start finding a lot of defects, report them. Then it becomes more and more difficult to find the defects at the end. Yeah, at some point in time, it will be the defect popping rate will start becoming lower and lower. Yeah. Now, I've been in the popcorn making business for quite a while. All right, And I know sometimes what happens is you get a bit greedy, yeah? You say, I want to have more popcorn, because if you take it off too early, then you have unpopped popcorn, and you don't need those, they don't taste very well. On the other hand, what happens if you keep it too long? Some of the popcorn will burn, yeah? So again here, the optimal is when your popping rate goes below 2.5 seconds. I don't know by experience, yeah? This is the exact number. Now, if you look at the software industry and testing, at some point in time, your defect rates start decreasing. You will never wait till you find the last defect, because then you have all the, it would be simply too expensive. Yeah. Now, this is the view that sometimes we're forgetting in testing. It's all about balancing quality and time to market. Now, we tend to think of, we need to find all the defects, want bug-free software. I got the gentleman from there saying that, which is a nice and noble idea. But you have to remember, there are equally demands coming from other parts of the organization, from the business side, from development, from the product owners, who want to ship out the product to the market to gain market shares and everything, yeah? Now, one important thing, and I think those of you who have also been here in the panel discussion, we know that there's a wide range of business spectrum, of which your software might be one end or the others or something in between. Now, I have this very nice device on my hand. This basically, it monitors how many steps I take throughout the day, and the pulse, and even sometimes if I get a phone call, it will pop up here, so I can even speak here, which is a bit silly because I need the phone to be nearby. But anyway, that's a different story. But anyway, this is a piece of software, yeah? I have a piece of software inside of this device. Now let me ask you, what happens, let's say, if it misses the step count by 15, 20%? Will you care? Maybe, but you can live with it, yeah? Now, I'm also, I come here to Kuala Lumpur. I need to have some local currency, some ringgits. So I went to the ATM. Now, I wanted to get some money. Now, what if, it's just 10, 15% of the currency, of the number of bills is wrong? Do you care? Yes. Now, that's my point. So your software might be in other extremes, yeah? You might be developing software for devices like this, or the new version of Candy Crush or whatever, or you might be doing some safety-critical regulated software, and it all depends on that context. So back to the discussion of how much testing is needed, it's very context dependent. I'll get back to that in a second also. All right. So let's now put some look at math and numbers. I know it's very late in the afternoon, you must be tired, but now I'll bore you with some more theoretical stuff, okay? Cost of quality. This is coming from a chap whose name is Crosby. Crosby said that cost of quality is composed of two components, cost of conformance and the cost of non-conformance. What do we mean by that? Cost of conformance, this is the cost of preventing defects, cost of detecting, doing the actual testing, the cost of internal failure before it hits the market, before it's shipped. Cost of non-conformance is the cost of external failure, if it fails after going live, yeah? Or if there are other related costs. For example, let's say you're making a system, you're sending it out, and you have some penalty clauses saying if you find, for example, more than 500 severe defects, you get $1 million fine or whatever. These can be additional costs associated with that. So Crosby said that the total cost of quality is a combination of these two. All right? Let's take another formula. This is from a business point of view. Now we call a concept of potential value and net value. All right? So net value is basically the potential value minus the cost of quality. Now, if you have no cost associated with quality, then your potential value will be the same as net value, all right? And when we talk about profit margin or return on investment, basically it's the potential value divided by the net value. This is from a business point of view. So how do you maximize your return on investment? Anyone? Complicated formulas? Sorry? Reduce the cost of quality. Yeah? All right. This is coming from a business point of view. This is basically a typical reaction from the business. We want to reduce the cost. We bring down the quality. We bring down the cost by reducing the cost of quality. And this is what we're facing on a daily basis. Yes? All right. I know in Europe we say this is all Greek to me. I don't know what you say here. But basically, we're talking about two languages. You know, it's a bit like when a husband and wife go to this marriage consultant and the man and wife say, my husband and wife don't understand me. Talking two different languages, yeah? So the language of testing is quality, defects, test coverage, risk, yeah? The language of this business is a bit different. They like to talk about scope, time, money, and of course risk. And sometimes they say, oh yeah, okay, quality is also something we care about. But the point is, there is a gap between these two worlds, the business world and the quality world. And the way we can bridge that gap, I would recommend, is for us to learn the language of business, translating testing into business language. All right. So the way we typically do that in testing is to demonstrate the cost of quality, or actually lack of quality, to the business. Now back to a discussion before on what is the right level of testing. Let me ask you a question. Is it your responsibility to determine how much testing is enough? Who needs to make the decision? Is it your decision to make a decision whether we should ship a product or not? You think yes. So basically you're taking then the full responsibility. You're shipping the product, you're making that decision. What if it goes wrong? Then they can blame you. But who put in the defects?
No, if you are raising many birds and many defects, and if somebody is taking direction that it can be moved, then it's wrong, right?
Unfortunately, this is what we see in many places, that basically testers, test managers asked to make this decision. You know, project manager or product manager will come and say, look me deep in the eyes, shall we release it or not? Yeah? And then you say, yeah, let's release it, or no, we shouldn't. In reality, I would say it's not your decision, it's not our decision. Back to the original discussion about information, the best thing we can do is provide all the data, put it on the table of our stakeholders, product, they say, this is what we have found. We have found so many defects, we have a number of unresolved defects, these are the performance issues we found, these are the things, this is the performance system right now, these are the security vulnerabilities we have discovered. Some of them remain open and so forth. And make those data and put it on a table of the stakeholders. I don't want to put my head on the table, on a block, and say, hey, I'm taking responsibility and ownership of this product. I didn't put the defects in. Someone else did that, yeah? All right. There's a common saying that if you don't know where you're going, any road will get you there, yeah? Another one, maybe from a testing perspective, is if you don't know where you're going, how will you know when you've arrived, yeah? So basically, for us to translate testing into business language, be able to establish a few measurements, a few metrics that can enable us to communicate that message. Now, I know there are different views on metrics and usage of metrics. My view is that use the metrics that are relevant to you to build your message and get it across. Now, don't use the metrics just for the sake of using metrics. Have a pragmatic approach. And I'll give you a couple of examples in a while. All right. So let me give you an example. So basically, if you look at the end-to-end life cycle, there are several phases you go through. You have dynamic testing, you have static testing, you have different levels of testing. You have unit testing, integration testing, system integration, UAT, and so forth. Now, you can potentially, from a business point of view, invest in covering all these areas. You can also include covering the different, back to the discussion about quality, covering all the quality attributes. I want to test for performance, security, and so forth. Obviously, the downside, it comes with a cost. Each and every one of them has a price tag associated with it. Now, I believe in full openness. So what I will do is I'll actually create the breakdown structure of all my requirements, all my quality characteristics, put the testing effort associated with that, and again, pass it on to the stakeholders, and let them help me decide which tests are relevant or not. I can come with some recommendations because, I'm experienced, I've done it before, I know how to do this, but ultimately, I'll let them make that decision. And let them also face with the consequence if they select to choose, for example, for slightly less than what we recommend or what we see useful. All right. So again, what kind of information will you have? Well, there are different aspects, metrics that you can establish in software development testing. I will not go through all of them, but these are just examples. Defect insertion rate, application factor, defect removal effectiveness, time to resolve a defect, cost of a defect resolution, rework rate, equivalent manual testing effort for automation. I'll cover a couple of examples in a while, all right? And again, also demonstrate what is the cost, for example, of compressing schedule or having unexperienced personnel as part of the testing group. All right. And at the end, of course, I want to quantify by putting a dollar value on what is the cost of avoiding doing testing or not testing that particular requirement. Let me show you an example. Now, I've created the model, and again, just whenever I show a model, there's always, the caveat at the end of it, will that work for me? And the simple answer is no, it will not work for you because my context is different than yours. There's no saying that all models are wrong, but some are useful. Now, this model has been useful for myself. I use that to create basically a business case for testing. I'll show you a spreadsheet. I think we have a few minutes for that. All right. And I know already the question I'll be getting. Will you be able to share this spreadsheet with me? Yes, just send me an email. I'll send it to you. I'll send it over to Mastura, and she'll distribute it so you can get it. All right. But basically, as mentioned, just be careful. Now, the idea is to try to quantify what is the cost of each and every activity in testing. Now, we've created that model, taking into the factor insertion rate and so forth. So here, for example, I have an example of a product. Talking to business, I know that if we ship it to the customers, the value will be $4 million. This is the kind of value the business expects from that product. All right? Now, I'm guessing, based on experience with other projects, that probably 500 defects will be created throughout the life cycle. Yeah, developers are very creative, and defects do get produced. And this is very conservative set 500 defects. Now, I also know that typically defect will be split in different phases, and here I built in some of the models taken from Barry Bain, actually. And I expect that actually about 280 will be coming from the requirement phase, 203 will coming during the design, and 44 will coming throughout coding. Now what will happen, of course, if I do nothing, no testing whatsoever, what will happen if you see that basically they have a lot of, and these defects will just have their way through the life cycle. They will tend to breed along the way. So one defect in requirement can become 3 defects in design, and these 3 defects in design can become 5 defects in coding and so forth. So it means that potentially I'll be shipping about 904 defects, all right? Now, if you look at here, I have, this is the actual cost of defect resolution. Here, it is 0. I've removed all testing activities. I'm not resolving any defects, all right? So this is the cost of 0 testing. Now what will happen, based on my historic data in the company, is that it will give a lot of issues in production support, yes? So it will actually, the cost will be $6 million, $6,800,000. So looking at the business case, the margin, profit margin, ROE, is minus 72%. Now we're talking directly to the business. Do you think they like this message? No. All right. So what I'm doing is, now I'm starting to put in some testing phases. All right, I want to do some unit testing. I want to do some UAT. And as you can see, what happens is, of course, cost in production goes down. However, cost for doing these activities will go up. Yeah? Now, number of defects that are being released has gone down to 200 or 199. And the profit margin is 53%. You can also see the number of time to resolve. So it might be in a situation where I need, basically, I want to go further ahead to maximize ROI because I have basically more time for that. So I can start including another number of activities. Now, basically, this is my model. Now, this is not a perfect model, but my point is, this gives me the means to communicate with the business side. Now, I've translated all these the testing language into business language. And I can have a meaningful discussion, hopefully, with the business side and start showing them the consequence if we remove some of those activities. I can, of course, add also automation, a number of factors. Actually, if you open the spreadsheet in the beginning, there's an introduction showing basically how to use it, so you can have that for you read. All right. So basically, as mentioned, testing requires investment in different things, as we're discussing. Back to the first slide, where you saw the testing phase, resources, tools, equipment, and so forth. And business stakeholders, of course, we want to expect healthy return on investment. So when I come and ask for the latest automation tool, they will tell me, show me the money. Yeah, you've seen the movie, show me the money, show me the money. Want to know what is the return on investment. Let me give an example. I've used this for automation. Now, automation can be a tricky thing because the typical question is from your management is, what will we get out of this automation? Yes. So I've actually created basically an example where I've just taken an automation project, estimated the equivalent manual effort. So if we say remove all the automation and we run the whole thing manually, that will be the cost. Oh, sorry. So here, for example, this is taken from a real project. Development cost has been 11,000 euros. Maintenance is 5,000, and tool licenses is 16,000. So in total, I've spent 33,000, or I tend to spend 33,000 euros on this automation project. Now, what I've also done, I've just put a counter that will calculate the number of test cases that has been executed through automation. And it came up that we have executed 15,382 test cases. Now, I know that in average, if I want to do that manually, it's about 25 minutes per test case. So just doing the math, it means that in order to execute all test cases, it will cost me 6,409 hours, which is equivalent to 100,000 and 11,000 euros. So in terms of ROE, basically you have the savings here and we have the total here. So this is a return on investment of 324. Is that a good investment? Is that a good return on investment or not? No. Now the point is, I'm actually a bit manipulating with the numbers here. Why? Because you might not want to run everything manually if you don't have the tool. But this is enough for me to have a discussion with my management in order to make the business case for automation. Get the point? Because there are a lot of things that I'm missing. What I didn't have, for example, is how much effort did we save in the entire system testing as a result of using automation? What about the tester satisfaction that we didn't need to have them doing all the regression testing in the weekends and in the holidays at night, so forth? There's another factor that I didn't factor in. How much did we speed up on the development side? The fact that they're able to get the feedback immediately and able to resolve the issues. How many errors did we prevent going live? And last but not least, how did it impact the quality and user satisfaction? I did not put dollar values on those, but I could have done so, which have even made my case better. All right? So what's my point? My point is these metrics are not perfect. They are presenting one side of the story, but this is presented in a language that is understood by business, which is enough for me to enable the business case for either investing in tools or doing certain testing activities and so forth. So the question is, what about Agile? What I've presented so far, and also the spreadsheet I've shown, is predominantly targeting waterfall-based development cycles. What about Agile? You've probably heard about Agile, you know, the Agile Manifesto. Back in the 90s, a few guys met in some kind of a skiing resort, but instead of going skiing, they discussed development and testing. Kind of strange kind of thing to do, yeah? But anyway, what came out of it was this Agile Manifesto, which is all about working software, customer collaboration, or responsive to change. Now, what they typically promote in Agile is cross-functional teams, where you have teams composed of multiple people coming from support, from development, from project management, working all collaborating together. Now, obviously, if this is the case, then segregating the duties and responsibilities might not be that easy. So meaning actually quantifying the actual effort you spend on the different testing activities, again, might not be that straightforward. And traditional metrics might not work either. So the metrics that I've shown before might have some constraints or might have some limitations when it comes to Agile. However, one thing is for sure is that Agile is all about minimizing waste and increasing value for the customer. For me, this can be translated into the language of business, money. Now, looking at some of the Agile metrics, I've seen some of those: planned value, earned value, actual cost. For me, those can equally be translated to some financial figures. An example, anything that, for example, can affect the velocity of the team is something that has a financial impact. So if you can communicate with the business, the stakeholder saying, this will make the velocity of the team go down, I'll grab their attention. Looking at, for example, another thing, this is the content of the different cycles. What we have here is number of defects, change requests, and features. What is surprisingly high is, for example, number of change requests. It means for me that we're not capturing, for example, the user requirements correctly in the user stories. So this can give me an opportunity to invest, for example, in better tools or better methods for increasing that part, for improving that part. Also, I see a lot of defects actually slipping from one iteration to another. This can give me the power to communicate back to them and saying, hey, actually, you're actually not creating value. You're minimizing, you're actually creating a lot of waste throughout that process. All right. So my point is, there are, of course, data sources available out there, and I've used some data sources to create my model in a spreadsheet. But what I think for sure is that your data is much better than mine. So the best thing you can do is look historically at your projects, start collecting some of the things that are easy to collect, and start putting a dollar value on it. Now, we've discussed a lot about metrics and numbers. Just a word of caution. We're not robots, are we? So remember, not only trust the numbers blindly. You all have your experience, your judgment, and you should not take away that and replace them by dumb numbers, so to speak. So the idea is, if you see two extremes, you have one extreme where you base the whole thing on data, on metrics. Another extreme is basically when you base the whole thing on emotions. Yeah? I would say the best thing is to be something in between. Still, use your judgment, your experience, and substantiate that with some numbers that can help you make the business case and communicate with the business. All right? All right. So one part of it is looking at numbers. Last part of it is the testing that's getting done is only as good as the testers doing the work, yeah? So last thing I want to address is how can you increase your own value? How can you get a better salary? What is happening is basically, again, we discussed this during the different sessions, we're going digital, putting user in the center. We have so-called a shift left, starting as early as possible, shift right, basically having direct communication and with operations and having continuous integration, continuous delivery. We have shift up, basically moving and having the discussion directly with the end users and the business. And you have shift down, yeah, because sometimes you also want to improve the collaboration with the developers. So in order for, my tip for you, if you want to increase your value, is invest in those skills. First one, domain insight. This is shift up. If you're working in a bank, in insurance, having good understanding of your banking domain, of your insurance, is something that can provide value for the work you've done. You'll be able to do better work if you have this knowledge. Another one, modeling. I'm not referring to walking the catwalk, but modeling of business processes, understanding basically the end-to-end business scenarios and be able to model those. If you have that skill, your value will increase. Programming fundamentals. I'm not saying that you should be able to program like the developers, but having understanding of some of the basic concepts of development and programming that will enable you to have some meaningful discussion with your fellow developer. So, for example, you can help him or her prevent some defects from ever emerging by reviewing the code, having code walkthroughs, and so forth. Automation. And here I'm looking at not only at test execution automation, but holistically at the end-to-end lifecycle approach, investing in the areas where tools are required for security testing, performance testing, even from starting from requirement, doing the requirement ambiguity analysis, for example, and data management, data masking, and so forth, until you can do the execution, regression test automation, and so forth. Techniques. Why do I mention techniques? This should be fundamental. Now, you probably also, many of you have done the ISTB training. How many have got the knowledge about equivalent partitioning and boundary value analysis? Have you heard these concepts before? Now, I don't want to ask this question, but just think, how many of you are actually using those techniques at work? Okay. Some of the research that we've done show that a lot of testers know about the technique, but many are not applying those. All right? There's a lot of value in those techniques. The minute you start applying those, you will get more value, more insight into the applications, and more ability to find defects and prevent those. Lateral and system thinking, this comes after a while, basically this thinking out of the box. And of course, this is not something that can come from one day to the other, but basically having this untraditional thinking of how you can do the testing is also something that can increase your value. And last and not least, leadership. I'm not talking about test management, but the ability to lead teams and to motivate them and to create value by basically having good teams that are motivated and can do high level of quality testing. All right. So my final message is that if testing costs more than not testing, then don't test, all right? But you better have the data back up your decision, all right? With these words, I have nothing more to say, so thank you very much for your attention.